A number of you have been having a little bit of problem calculating the self-weight of our reinforced concrete beams. And before we go on to our design project, I thought I had better review how to calculate self-weight. The fundamental principle behind this is that weight equals unit weight times volume. I try to avoid the word density because density is mass per volume, so unit weight is weight per volume. You need to know the unit weight of structural materials, and those are concrete. Normal weight concrete is about 145 pounds per cubic foot, and steel is 490 pounds per cubic foot. So reinforced concrete, let's say I said a typical percentage of steel in a beam is 1%. It'd actually be higher for a column, maybe 4% for a column. But for a beam, it's 1% steel. So you would have 99% of it would weigh 145 pounds per cubic foot, and 1% of it would weigh 490 pounds per cubic foot. And for our metric friends, I apologize. We use imperial units here in the US. I'm multiplying that out right now. That comes out to 148.148 PCF. And so for our class, I've been saying 150 PCF is good as a unit weight for reinforced concrete. I never really thought about it for columns with 4% steel. Let me look at that. 96% at 145, 4% at 490. Oh, be interesting. I've never actually done this before. Oh, that's a lot more than I thought. 159 PCF. So columns are about 160 pounds per cubic foot, and beams are 150 pounds per cubic foot. You could do that if you want when you do your design project. I'm just using 150 for everything, but yeah, I've never done that before. Okay, so I'm going to just use 150. So I'm going to use 150 pounds per cubic foot, or 0.15 kips per cubic foot. And for our metric friends, this is a weird thing. We say 1,000 pounds equals a kilo pound. It's not a real unit. And we take the K and the P and kip. So we put an I in there, kip, and or we just put K. So in these videos, if you see K, it means 1,000 pounds. Back to what we're doing. The weight of something is a unit weight times the volume. Let's talk about slab unit weight. Typically on a slab, you want to know the load per unit area. You want to know weight per unit area. And the unit area in imperial we use is a square foot. So we want to know the weight per square foot of slab. So let me try and draw that. So here's 1 square foot, 1 foot by 1 foot, and it has a certain thickness. So the volume is 1 times the T, thickness. And so the weight for 1 square foot is the volume times the unit weight. I'll use gamma. So 1 times T times 0.15 kips per cubic foot. And that will be 0.15 T. There you go. Let's say you had a 4-inch slab. That's a 1/3 of a foot because it's 12 inches per foot. So Q, the unit weight, Q of the self weight, 0.15 times the thickness of 1/3 per foot squared, or 50 pounds per square foot. There you go. Let's get beam unit weight. Beam not unit weight, self weight, I guess. Sorry. Beam slab self weight, beam self weight. Okay, same thing. It's just the volume times 150 pounds per cubic foot. In a beam, this W, we want it in weight per length. And typically the length unit we use in the US is feet. So we want to know how much 1 foot of a beam weighs with a certain cross-sectional area. The volume is the area times 1 foot. Therefore, the self-weight per foot is area times 1 times 0.15 or 0.15 area. For example, if you had a 12-inch by 24-inch beam, the area is 12 times 24 square inches, and 12 squared is 144. And so 144 square inches is 1 square foot. And that comes out to 2 square feet. And W self-weight equals 0.3 kips per foot. And then finally, column self-weight. Typically, we just want the total load in pounds. And so that's easy. The weight of the column is just the volume times 0.15. And you all know how to calculate the volume, area times length. I'm not even going to bother. Okay, that's how you get self-weight.